Warning: this video will talk through the solution to a logic puzzle. If you're not into that kind of thing, it will be very, very boring. I've always loved puzzles. When I was a kid, I would sometimes receive puzzle magazines as birthday or Christmas gifts. In high school, I had a subscription to Games Magazine. Now, thanks to the pandemic, I've had lots of free time on my hands, so I've been buying puzzle books again. I think puzzles, and logic puzzles in particular, can be a good way to train a child's brain. Logic puzzles train you not to jump to conclusions and not to overlook possibilities. These are useful critical thinking skills to have in everyday life when trying to tell the difference between fact and fiction. I've always loved the beauty of mathematical proofs. In mathematics, if not always in real life, there are ways to know that something is true. If there is a proof that something is true, you don't have to take anyone's word for it. You can follow the reasoning of the proof yourself and see that it makes sense. I've recently discovered that when solving a logic problem, I'm less likely to make mistakes if I write down every step of the logical path I take toward the solution. That way, if I make a mistake, I can go back over my path and see where I went wrong. And it would be a shame to let all that writing go to waste. I decided that if other YouTubers can record themselves solving puzzles, then so can I. This isn't going to be a real-time solve, though. Solving this puzzle originally took a couple of hours, and not all in one sitting because I didn't know the logical path to the solution until I tried everything. Still, I hope you'll forgive me if I sometimes describe my thought process as if I'm going through it for the first time, for dramatic effect. This particular puzzle is a figure logic puzzle from Dell's Math and Logic Problems magazine, volume 162, with a cover date of January 2020. I've tried to recreate the page as best as I could using photo editing software. Figure logic puzzles are like crossword puzzles, except instead of entering words into the grid, you're entering numbers. In most figure logic puzzles, there's a clue for every entry in the grid, and they tell you how each entry relates to other entries. No clue on its own contains enough information to give an answer, so you have to bounce around from clue to narrow down the possibilities for each entry. This is a challenger figure logic puzzle with what appears to be only 7 clues, but that's a little misleading. Almost all of these clues contain multiple clues within them. Every entry in the grid is mentioned at least once in this set of clues, so the writer could just as easily have given each entry its own clue. Instead, it looks like similar clues have been grouped together in order to reduce the apparent number of clues, making it look tougher than it actually is. Let's read through the clues to get started. Number 1. In 11 across, 12 across, 14 across, 23 across, 26 across, 4 down, 11 down, 13 down, and 20 down, each digit after the first digit is consecutive in some order with the preceding digit. Now you see what I mean? There are 9 grid entries listed here. This could have been 9 clues. Anyway, let's think about the implications of this clue. If every digit in these entries is consecutive with the next, then these entries have alternating odd and even digits. That's useful information. One technique I often find helpful in solving this kind of puzzle is to try and figure out which squares in the grid must contain an odd digit and which must contain an even digit. I'll lightly pencil in an E for even or an O for odd. It's helpful when I don't know how to begin or when I get stuck. Clue number 2. In 1 across, 19 across, 24 across, 5 down, and 8 down, one digit is the sum of the other digits. Clue 3. In 16 across, the sum of the first 2 digits is the same as the sum of the last 3 digits. In 2 down, the sum of the first 2 digits is the same as the sum of the last 2 digits. You can see that some of these clues aren't going to be useful until we have some digits already placed in the grid. Clue 4. 3 across is 1/2 of 4 down, 9 across is 1/9 of 12 across, 19 across is 1/4 of 21 across, 15 down is 1/4 of 17 down, 16 down is 1/6 of 11 down, 18 down is 1/5 of 11 across. Ha-ha! Now this will give us some information about which answers are odd and which are even. Combining this with clue 1 and that technique I was talking about with the E's and O's for even and odd will give us a good start to the puzzle. Clue 5. In 10 down, each digit is a multiple of the second digit, which is not 1. That's strangely specific. Clue 6. 6 across is the difference between 14 across and 13 down. 1 down is the difference between 1 across and 4 down. 6 down is the difference between 26 across and 23 across. 22 down is the difference between 8 down and 18 down. Clue 7. All 3 digits of 25 across are the same, but only 2 of the digits of 6 down are the same. 7 across's digits are the same as 20 down's digits in some order. Okay, that's all the clues. I started this puzzle by going back and forth between Clue 4 and Clue 1. Clue 4 says 3 across is 1/2 of 4 down, therefore 4 down must be even. The last digit of 4 down is also the last digit of 12 across, and both of these entries are listed in Clue 1, which says that each digit after the first digit is consecutive in some order with the preceding digit. All the entries listed in Clue 1 follow this rule. We'll call this the consecutive rule from now on. A side effect of the consecutive rule is that the digits of 4 down and 12 across alternate between odd and even, so we can pencil in more E's and O's, not just in those two entries, but also in any other entries listed in Clue 1 which intersect them. Keep in mind that these O's are the letter O, not the number 0. Clue 4 also says that 9 across is 1/9 of 12 across. Since 12 across is even, 9 across must also be even. 19 across is 1/4 of 21 across, so 21 across must be even. 15 down is 1/4 of 17 down, so 17 down must be even. But wait, the last digit of 17 down is in 26 across, which was also listed in Clue 1, so it follows the consecutive rule, and we can add more pencil marks. 16 down is 1/6 of 11 down, so 11 down is even. We already figured that out. And finally, 18 down is 1/5 of 11 across. This means that 11 across is a multiple of 5, so it must end in either 5 or 0. We already know that it ends with an odd digit, so it must be 5. That gives us our first digit in the grid, and since 18 down is 1/5 of this odd number, 18 down must also be an odd number. This is as far as we can get with the E's and O's for now. Now it's time to figure out some digits. 3 across is 1/2 of 4 down. 3 across has 3 digits, which means it's less than 1,000, and 4 down has 4 digits, which means it's at least 1,000. If you double a number that's less than 1,000, you get a number that's less than 2,000, so the first digit of 4 down must be 1. Now notice that in 4 down and 11 across, we've got a chain of consecutive digits connecting the 1 and the 5. We can bridge that gap with 2, 3, and 4. This means 4 down is in the 1200s, and if 4 down is in the 1200s, then 3 across, which is half of 4 down, must be in the 600s. So now 11 across has to be either 2, 3, 4, 5 or 4, 3, 4, 5 because of Clue 1's consecutive rule. 18 down is 1/5 of whatever 11 across is, so 18 down is either 469 or 869. We can at least fill in the 6 and the 9. Nice. I can't believe I said that. This is as far as we can go using just Clue 1 and Clue 4. I'm going to move on to Clue 5. In 10 down, each digit is a multiple of the second digit, which is not 1. We know the second digit is odd. It can't be 5 because any multiple of 5 greater than 1 times 5 is a 2-digit number, not a single digit. That might work if 10 down were just a string of 5s, but we can see that 10 down has some even digits in it. So the second digit isn't 5. The same argument rules out 7 and 9. The multiples are just too big. So, if it's odd, it's not 1, and it's smaller than 5, it must be 3. 10 down is made up of 3s, 6s, and 9s, which means those even digits must be 6s. Now 9 across ends with a 6. Clue 4 says that 9 across is 1/9 of 12 across, so 12 across ends with 4 because 6 times 9 is 54. And now that we know what 4 down is, we know what 3 across is. 12 across, 13 down, and 14 across all follow Clue 1's consecutive rule. This means there must be a chain of consecutive digits connecting the 3 and the 6, so we can fill in a 4 and a 5. Clue 2 says that one digit of 5 down is the sum of the other two. 5 down's first digit is 7, and its last is 4. 4 can't be the sum because it's smaller than 7, and the missing middle digit can't be the sum because 7 plus 4 is 11. So 7 is the sum, and the missing digit is 3. Clue 7 says that 7 across has the same digits as 20 down. 7 across isn't mentioned in any other clues, but we have 2 of its digits. What can we learn about the last one? We'll go back to our odd and even trick. Clue 6 says that 22 down is the difference between 8 down and 18 down. We know that 22 down is odd. It doesn't matter whether 22 down is 8 down minus 18 down or the other way around. 8 down must be even. Clue 2 says that one of the digits of 8 down is the sum of the other two. We have two digits, an odd and an even. It doesn't matter which one is the sum. This can only work if the first digit is odd. Either the two odds add to the even, or one odd adds to the even to get the other odd. So now 7 across has two odds and an even. Clue 7 says that these are the same digits as 20 down. And Clue 1 says that 20 down and 23 across both follow the rule of consecutive pairs. Therefore, 20 down is an even digit between two odd digits, and so is 23 across. The middle digit of 20 down is the same even digit from 7 across, which is 2. Clue 7 also says that all three digits of 25 across are the same, so they're all odd. Now let's work on 19 across. The last digit of 19 across is also the last digit of 10 down. Clue 5 says that every digit of 10 down is a multiple of 3, so the last digit is 3, 6, or 9. Clue 4 says that 19 across is 1/4 of 21 across, which ends with a 6. 9 times 4 is 36, so 19 across must end with 9. Clue 2 says that in 19 across, one digit is the sum of the others. Well, 19 across has a 9 in it, and 9 is the biggest possible digit, so that must be the sum. And the first three digits of 19 across must add up to 9. Now, we don't want the first digit of 19 across to be too big, because Clue 4 told us that 19 across times 4 is 21 across, and they're both 4-digit numbers. So the first digit of 19 across can't be any bigger than 2, otherwise 21 across would end up as a 5-digit number. The second digit of 19 across is the first digit of 20 down, and 20 down follows the consecutive rule from Clue 1, so that digit is either 1 or 3. So now we can narrow 19 across down to 4 possibilities: 1179, 1359, 2169, 2349. The first digit can only be 1 or 2, the second digit can only be 1 or 3, and the third digit, according to Clue 2, brings the total of the first three digits up to 9. Let's multiply each of these numbers by 4 and see what we get for possible values of 21 across. Now, as you can see, two of these answers begin with an odd digit, but in the grid we already marked the first digit of 21 across as even, so we can eliminate those possibilities. The remaining two possibilities both have 1 as the second digit of 19 across. It's not a lot of information, but it's more than we had before, so we can put that 1 in the grid. Now the deductions come pretty fast. Clue 7 says that 7 across has the same digits as 20 down, so now we can fill in the missing digits in both 7 across and 20 down. All three digits of 25 across are the same, so we can fill those in too. This gives us 3 as the last digit of 16 down. 16 down is 1/6 of 11 down, so 11 down ends with an 8 because 3 times 6 is 18. This gives us the first digit of 21 across. And if we look at our list of possibilities from before, we see that 21 across must be 8676, and 19 across must be 2169. Both 11 down and 11 across follow the consecutive rule from Clue 1. Since the last digit of 11 down is 8, the first digit, which is 4 squares away, can't be any smaller than 8 minus 4, which equals 4. And the first digit of 11 across can't be any greater than 4 because it's consecutive to the 3 next to it. Here's a general principle that comes in handy. If the maximum possible value of a square and the minimum possible value of the square happen to be the same number, then that number is the correct value of the square. So 4 is the digit that goes in that square, and we can fill in the rest of 11 down with consecutive digits. 18 down is 1/5 of 11 across, and 16 down is 1/6 of 11 down. 9 across is 1/9 of 12 across, so 12 across is a multiple of 9. The digits of a multiple of 9 always add up to a multiple of 9. The digits we have for 12 across right now add up to 16. We can get it up to 18 by making the first digit a 2. And now we know what 9 across is. We don't know what the last digit of 8 down is yet, but since 22 down is the difference between 8 down and 18 down, we can at least fill in the middle digit of 22 down. One digit of 24 across is the sum of the other two, and since 9 must be that sum, we can fill in 24 across. Now here's where it gets tricky. I'm going to need to remember multiple possibilities for some of the squares, so you'll see me pencil in multiple digits in a single square. One digit of 8 down is the sum of the other two. 1 can't be the sum because it's smaller than the 5. If 5 is the sum, 8 down is 154. If the last digit is the sum, 8 down is 156. Since the difference of 8 down and 18 down is 22 down must be 713 or 715. So the last digit of 26 across is 3 or 5. 15 down is 1/4 of 17 down, so 17 down is a multiple of 4. A number is a multiple of 4 whenever the number formed by its last two digits is also a multiple of 4. So the last two digits of 17 down must be 80, 84, or 88. But the last digit of 17 down is also in 26 across, which follows clue 1's consecutive rule. So 17 down's last digit has to be consecutive with that 3 or 5 next to it. Therefore, the last digit of 17 down must be 4, which means the last digit of 15 down is 1. With 3 of the digits of 17 down determined, there are only two possibilities for the first digit. Either 15 down is 421 and 17 down is 1684, or 15 down is 921 and 17 down is 3684. Now we're ready to work on clue 3. In 16 across, the sum of the first two digits is the same as the sum of the last three digits. We already have a 7 in each section of the number, so we need to make the second digit equal the middle digit plus the last digit. The last digit, as we just saw, is 1 or 3. The middle digit is in 13 down, which follows the consecutive rule, so it's 4 or 6. These two digits have to add up to the second digit of 16 across. One of these digits is even, the other is odd, so their sum is odd. Therefore, the second digit of 16 across must be odd. This digit is part of 10 down, and if you remember, all the digits of 10 down are divisible by 3, so this digit is 3 or 9. Well, the middle digit of 16 across is already bigger than 3, so the second digit can't be 3, it must be 9. Now we can finish 16 across. 17 down is done, and 15 down is 1/4 of 17 down. 6 across is the difference between 14 across and 13 down, so it's 200. The first two digits of 2 down have the same sum as the last two digits, so now we can fill in 2 down. 1 down is the difference between 1 across and 4 down, not too hard to figure out. 6 down is the difference between 26 across and 23 across, so 26 across must begin with a 3. Clue 7 says that only 2 of 6 down's digits are the same, which means the difference between 26 across and 23 across is not 222. This means 26 across is not 343. It must be 345, so 6 down is 224. Finally, 22 down is the difference between 8 down and 18 down. And that finishes up the puzzle. This is my first attempt at making a video like this. I've got 2 more in the works. The next video will feature a logic puzzle with a lot less math in it. I'm trying to think of ways to make the next video more interesting. Maybe some background music? A cartoon avatar of me appearing on the screen from time to time? Unnecessary star wipes? We'll see. Thanks for watching.